We're going to factorize cubic polynomials and we're going to get complex linear factors. So by example, we have a given p of z and it says p of z equals 2z cubed plus 9z squared plus 14z plus 5. We have three things to do. We've got to use the factor theorem from our previous knowledge to show that z plus 2 minus I is a linear factor of p of z. Write down the another complex linear factor and then find all of them for p of z over C, the set of complex numbers. In part A, let's use the factor theorem now. Alright, so we know from our previous work, the factor theorem, where alpha is a complex number, z minus alpha is a factor of the polynomial if and only if p of alpha equals 0. So we need to identify alpha first. So looking at what we've got here, z minus alpha, we should have alpha equals negative 2 plus I. So we need to determine p of negative 2 plus I. So let's do that. I find it a little bit nicer to write it as p of I minus 2, by the way. So let's go, we've got the given polynomial up there, p of z. Making the required substitution, we get the following there. Now, from Pascal's triangle or otherwise, or i.e. memorize, the a minus b all cubed expansion is, in general, it's 3a squared b, sorry, a cubed minus 3a squared b plus 3a b squared, and lastly minus b cubed, and just note that there. That's one to know. As a rule of thumb, I'd learn expansions up to this here, by the way, or be able to use Pascal's triangle for a plus b or a minus b up to that. Okay, that should cover you for the work we're going to do. So following the pattern here, we've got 2 outside of I cubed minus 3 times I squared times 2, so 3 times 2 is 6, I squared, and we've got plus 3 times a times b squared, so we have 3i squared times negative 2. Sorry, correction, 3 times I times negative 2 squared. So negative 2 squared is 4, 3 by 4 is 12, so that'll be 12i. Sorry, I read the wrong spot there. And minus b cubed. Using our perfect squares expansion for the second term there, so we have the first squared minus 2 times the first times the second plus the second squared, and then the next term we have 14i I minus 28 plus 5. So that's fully expanded now on that line. Collecting like terms and simplifying, we've got 2i cubed, we've got negative 12i squared plus 9i squared is negative 3i squared. We have 24 plus 9 is 33. Oh, sorry, not the 9. Let me try that again. We've got 24i squared take 36 is negative 24i take 36 is negative 12i plus 14 is 2i. And for the constants, we've got negative 16 plus 36, that's positive 20. Take 28 as negative 8, plus 5 is negative 3 or minus 3. Now noting that I squared is negative 1, got 2i cubed. Now that will be 3 times negative 1, that's negative 3, so minus negative 3 is plus 3. And there's a minus 3 there, and a 2i on the end now. Middle terms cancel. Now we can unpack this as 2i cubed equals 2i times I squared. So that I squared is negative 1, so it's equal to negative 2i. So we've got negative 2i there, plus 2i, and that indeed equals 0, which is what we wanted, so yes, it's a factor. Let's write down part B, another complex linear factor of p of z. We had here, you'll notice just previously, p of negative 2 plus I, so we used the conjugates pair rule. So we had z, originally we had z plus 2 minus I, which is the same as z minus negative 2 plus I. To get the conjugate, we're finding the conjugate of this part here, hence the symbol, and we have negative 2 minus I in brackets, giving us that, and finally removing the brackets again, z plus 2 minus I. Okay, so the conjugate pair. Oh no, whoops, I copied this down wrong here. So if we go back to this step, that's correct there. I've copied this bit here wrong. It's the plus sign, failed to write that in. So then applying the conjugate, I've got to change that to subtraction there. So a translation error on my part. Sorry about that. Once you take the conjugate, that becomes negative 2 minus I, and then we have a plus there. That's more like it. That is the conjugate pair. The second part of the conjugate pair anyway. So that is a second factor there, z plus 2 plus I. Now for the last part, part C. We've got to now find all the other linear factors of p of z over C, so complex factors. So we've got 2 factors so far. I've listed them and I'm expanding that out now. You can see some like terms, so I've tried to color code them. Hopefully you can see that. These cancel, and I've put the z squared and the two 2z's together to make 4z. We've got these two cancel. We've got the 2z's are taken care of. We've got a 4 and an I squared. The I squared is negative 1, so we've got minus negative 1, which is plus 1, so that's 5. Now p of z is written there for convenience there, 2z cubed plus 9z squared plus 14z plus 5, and we've got this here, and we're just trying to find any other factors. Now the combination of these 2 factors makes this, and so through division we should be able to find another factor, a linear factor, because remember the question did ask us for linear factors. Some questions we can see the other factor by inspection, but not so this one. So using polynomial division, so to get this from z squared to 2z cubed, we need to multiply it by 2z, and multiplying everything else by 2z we get 8z squared and 10z there. Subtracting, we get z squared, and we get z squared plus 4z plus 5. That's handy because we just need now one more out, multiplying by 1, and we see we have no remainder, which is good. So we have 2z plus 1 as our last factor. So one final linear factor, and you identify that as 2z plus 1. Task completed.